Okay, in today's episode on Learn with Engineer Kinsley, we are going to be doing revision on practical physics, code physics 107. Let's get ready for some exam tips. Okay, we are going to be solving some massive questions, calculations, and theory questions that is involved in this particular course. The course credit unit is 1 and the exam standard. Okay, in this course, we are going to be looking at some necessary calculations from 1 to 5 in this part 1. In part 2, we are going to take series of examples too in preparation of this exam. Just stay with us on this YouTube channel and make sure you always like, comment, and share to your departmental groups and your friends. They need this. Okay, let's go back to the first question. I said, what is the relative density of a liquid if an object weighs 20 Newton in air, 17 when totally immersed in water, and 18 Newton when totally immersed in liquid? Okay, the first thing is to list out your parameters. You have object weighing 20 Newton in air, weight weight in air is 20 Newton. Weight in water, let weight in water is 17 Newton, and weight in liquid, what is given? I say weight in liquid is 18 Newton. Okay, the first thing we are going to do is to calculate the relative density. The relative density of liquid is upthrust. What is the meaning of upthrust? Upthrust is just simply talking about weight loss. Upthrust in liquid, upthrust in water. Okay, liquid first. Numerator is liquid. Upthrust in liquid all over upthrust. Water. Okay, so what are we having here? This weight in air is generally referred to as W1. Weight in water is regarded as W2, and weight in liquid is regarded as W3. So the relative density of liquid is now equal to W1 minus W3 all over W1 minus W2. So we can substitute our parameters. W1 is 20 Newton minus W3 is 18 Newton all over W1 is 20 Newton minus W2 is 17 Newton. So moving on, 20 minus 18 will give us 2 all over 20 minus 17 will give us 3. So 2 divided by 3 will give us 0.0.66666666666 Okay, approximately you have 0.67. Okay, let's check options that corresponds to this solution. Option B is correct. 0.67. Okay, that is for number one. Number two, if you look at number two, they said 0.2 gram per cm cube is in SI unit is dash. Okay, the standard SI unit is kilogram meter seconds and some others. But if we want to change gram to kilogram and want to change cm to meter, what are the procedures we are going to take? Look up. If you want to change gram, 1 gram to kilogram, you have 1, which is the gram, divided by 1000. It will be equivalent to 1 all over 10 raised to the power 3. And this is still equivalent to 10 raised to the power minus 3. Okay, so that is it in kilogram. In kilogram. Okay, if you want to change 1 cm to meters, you'll be having the 1 in cm divide times 1 all over 100. If you want to change cm to meter, you divide by 100. Or similarly, you have 1 times 1 all over 10 squared. Because 100 is 10 times 10, that is 10 squared, which is still equivalent to 1 times 10 raised to the power minus 2. Okay, moving on. You have, remember that this thing is in meters. But if you observe in the question, we are not talking about, this one is just gram. That's why it's in kilogram there. But this one, we are talking about cm to the power 3. So when we cube the meter conversion, we'll be having 1 times 10 raised to the power minus 2, which is still 10 times 10 raised to the power minus 2, all cube, meter cube. The difference between this and this is that I have introduced cube to what we have. Finally, you now see converting that young man there will be 1 times 10 raised to the power minus 2 times 3 will give us minus 6 meter cube. Okay, let's look at the question. The question we are converting is 0.2 gram all over cm cube. Okay, if you want to do this, it's very simple. Just write out the figure you have, 0.2. How you do it in your exam, it's very, very short. Multiply it with the conversion I have given you now. For gram, you are multiplying it with times 10 raised to the power minus 3. That is, to convert gram to kilogram, you multiply with times 10 raised to the power minus 3. But provided that that cm is cubed and you are converting it to meter cube, instead of being times 10 raised to the power minus 2, because of the cube, it will multiply it to be 10 raised to the power minus 6. Okay, this one is in kilogram and this one is in meter cube. Okay, moving on. When you multiply, you have 0.2 times 10 raised to the power. According to the law of indices, this is negative. When it goes up, it will change to positive. It will be minus 3 plus 6 instead of negative 6 kilogram all over meter cube. Okay, so we now have 0.2 times 10 raised to the power minus 3 plus 6 is 3 kilogram meter cube. So 0.2 times 10 raised to the power 3 is the answer, which corresponds with option number A. Okay, The number three question, they said an object has a specific heat capacity of 200 joule per kilogram per Kelvin. A specific heat capacity C to be 200 joule per kilogram per Kelvin. If 1 times 10 raised to the power 5 joule of energy, so the heat energy is 1 times 10 raised to the power 5 joule. Uh, to change its temperature from 20 degrees Celsius to 70 degrees Celsius. So we are having change in theta to be equal to theta 2 minus theta 1. Okay, theta 2 here is the final temperature, which is 70 degrees Celsius. So 70 degrees Celsius is the same thing with degree Kelvin. In the sense that even if you add 273 to change it to Kelvin and add to the first one, when you subtract it, it will still give you 50. So 70 degree Kelvin minus 20 degree Kelvin. If you subtract it, it will still give you 50 degree Kelvin. Okay? We use Kelvin in calculating. We don't use degree Celsius. Okay. So the formula of calculating heat energy is H M change MC change in theta. Okay, and that is correct. So our aim in the question, they say to determine its mass. So our aim is to make mass the subject. We divide both sides by the coefficient of M, which is C change in theta. We have H being divided by C change in theta. So mass, which is what we are looking for, is heat energy is 1 times 10 raised to the power 5 joule all over specific heat capacity is given to us as 200 joule per kilogram per Kelvin, and the temperature is being given to us as, that is the change in theta, to be 50 degree Kelvin. Okay, moving on, we have the mass, which is what we are looking for. Should be, you plug that young man in your calculator, you plug it in, you have 1 times 10 raised to the power 5 all over 200 times 50, 10, 10 kilogram. That is option number D. Okay, moving on to the next question, which is the fourth one. Okay, in this question that we just finished now, you see that you can find heat, you can find specific heat capacity, you can find the temperature change, and you can find the mass with that same formula, depending on the one you want to make the subject. So number 4, they said the standard error in the slope of a graph is 3, while its range and number of observed reading are 0.62 and 6 respectively. The vertical width scatter is dash. So the standard error in slope is equal to 4W all over NR, where W is vertical width scatter, which is what we are looking for in this question. N is number of plotting points, which is what is given to us as 6. N is given to us as 6. W is what we are looking for, known. The vertical range, they said the range is 0.62. So the standard error in slope is still given to us. Standard error in slope is given to us as 3. Okay, 3.0. So moving on, we can make the vertical weight scatter the subject, but let's substitute the parameters. We have the standard error in slope to be 3 equal to 4 multiplied by vertical weight scatter unknown all over. The number of plotting points is 6 multiplied by the vertical range is 0.62. Okay, moving on, we cross multiply. We have this times this. It will be 4W equal to this times this will give us 6 multiplied by 0.62 multiplied by 3. That is here. Okay, by cross multiplying, remember this is over 1. 1 times 4W will give us 4W. So moving on, we have 4W to be equal to 6 times 3 is 18. 6 times 3 is 18 times 0.62 will give us 11.16. Okay, making W the subject, you divide both sides by 4. So I have divided by 4 and divided by 4. I have that 4 will go with 4. W will be equal to 11.16 divided by 4 will give us 2.79. So is 2.79 the option? Yes, option A. That is all for this question. You still remember that the standard error in slope is given to be 4W all over NR. Okay, so the last question for this particular video. So please always share, subscribe, turn up your notification bell so that whenever we drop a very sweet and wonderful solution on things that is somehow difficult to you, you can engage it. Share to your friends, you subscribe. Very, very important. So they said in an experiment, the vernal caliper was used to measure the breadth to be. Breadth is given to us as 2.40 cm. And the thickness T is given to us as 0.45 cm of the meter rule. So we are talking about the meter rule. They said find the volume of the meter rule. But you know that volume V is length times width times breadth. Width is the same thing with thickness. Breadth is the same thing with height. Width and thickness is the same. Breadth and height is the same. So the standard length for meter rule is the standard length for meter rule is 100 cm. So when you plug it in here, you have 100 cm times width is given to us as 0.45 cm and breadth is given to us as 2.40 cm. So moving on, you have that volume is equal to 100 times 0.45 times 2.40 will give us 108. Cm times cm times cm will give us cm cube. So make sure you share this video for more amazing episodes. In our next episode, we are going to do some calculation question on 5 to 10. Then we'll take time and digest both the theoretical aspect and the calculation aspect. Just make sure you stay with us from the beginning to the end and turn your notification bell so that anytime you post, we don't have to come and remind you that we have dropped video. You get the notification. Thank you for watching this video.